Isosceles and equilateral triangles is where we're at today. And there are a lot of really special properties with isosceles and equilateral triangles because just like right triangles have special properties, in fact, right triangles have so many special properties, we're going to spend an entire unit just talking about right triangles. Okay? So we'll have a whole unit on that. And in fact, that's even going to include some trigonometry. You're going to learn some basic trig during that unit because right triangles are good for that. Isosceles and equilateral triangles are also pretty important. They've got a lot of interesting properties we can deal with. Not enough to give us a whole unit, but enough for us to spend at least today looking at. And kind of, I think, tomorrow as well. So, when we have an isosceles triangle, the sides of the triangle are called legs. The angle that connects the two legs here is the vertex. The side that is not congruent is called the base, and the side connecting a base with the leg is the angles, are referred to as base angles. So the first thing you want to do is make sure you understand the vocabulary of this, because you won't always get a picture. They may say you have an isosceles triangle with vertex of 16 degrees and base of 8. Just a written description like that. You need to know what those things mean so you can draw the triangle accurately. If I said a vertex of 16 degrees and a base of 8, I would know to draw a triangle, isosceles, with a vertex of 16 degrees and a base of 8. All right? Based on that. Now, don't think of base as bottom. I could have just as easily drawn my isosceles triangle this way, and my base is 8 here, and there's 16 degrees. Base does not have to be on the bottom. And that's going to be a common theme that you're going to see basically for the rest of the year. We can rotate that around. If I rotate this thing around, this is still the base. I think I grouped this picture. Yeah. If I rotate this thing this way, this side is still the base even though now it's on top. So don't get hung up on base meaning bottom. And like I say, that's a kind of a theme that'll follow us basically for the rest of the year. In geometry, many things have bases, but bases doesn't always mean the bottom of it. Okay? But that's B-A-S-S drum, not B-A-S-E.
This will be the base of the drum that you're talking about.
A little different. All right, so let's look at a quick proof about isosceles triangles. Because some of these facts are pretty easy to figure out. It says, given isosceles triangle ADC with legs AD and CD, and ray DB bisects segment AC. Prove angle A must be congruent to angle C. So, if I have an isosceles triangle, these sides are congruent. Definition, okay, so given isosceles triangle ACD, ADC, with legs AD and DC. That's given. What can I, now, just the same pattern we did with proofs earlier in the year. I'm given a statement. What parts can I prove are congruent based on that statement? Now, it's a little different, but I'm going to use, again, my vocabulary, isosceles triangle. I'm going to use the definition of isosceles triangle. And the legs can conclude, therefore, that AD must be congruent to DC. So just like we were doing before, we take a statement, and then we use something from that statement to find congruent parts. That tends to be our pattern. Next statement, DB bisects AC. That's given. If DB bisects AC, that means that AB is congruent to BC. Reason? What's the vocabulary word? Definition of bisects. Okay. What else do we have? Shared side. So DB is congruent to DB. Reflexive, because that's the property we use there. Is that enough?
Yeah.
What reason are we have congruent triangles? Side, 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 not CPCTC. It's triangle ADB congruent to triangle CDB. And if that's true, therefore, angle A is congruent to angle C. What's my reason? CPCTC, which stands for corresponding parts of triangles are congruent. All right? So we've just done a proof. But what I've just proven to you, what are angle A and C? What's the name of angle A and angle C in my isosceles triangle? What do you call those two angles? Those are the, according to their special name, they are the, no, they are the base angles. So I've just proven that in an isosceles triangle, the base angles must be congruent. That's what we've just proven. In an isosceles triangle, the base angles are congruent. Not only are the legs congruent, but also the base angles. Now, what that does is that means if I ever have to do something in a proof and showing that the base angles are congruent, I don't need to go through all those steps anymore, because I've just proven a theorem that says the base angles are congruent in an isosceles triangle, so I could always use the base angles theorem as a reason now. So we've just given ourselves a new reason we can use in proof as a major shortcut. If I know a triangle is isosceles, I can go jump straight to concluding base angles congruent because of the base angles theorem, which we just proven. So by proving that means we don't have to prove that anymore. We now know that it's true. The converse is also true. If the base angles are congruent, then the triangle must be isosceles. In other words, basically, if I have two congruent angles in a triangle, I'm also going to have two congruent sides. And they're going to be the sides opposite those angles. It makes sense. If I have two congruent sides, I'm going to have two congruent angles. The angles opposite the congruent sides. If I have three congruent sides in a triangle, how many congruent angles am I going to have? Three. They're all going to be 60. If I have three 60-degree angles, how many congruent sides am I going to have? Three. Equilateral triangle. Another strategy here is working with the triangle sums and stuff like that. Because if I have an isosceles triangle, which I'm going to say I have here, and I use up 100 degrees of that with my vertex angle, how many degrees are left for my base angles? My two base angles? 80. There's 80 left, and I have to, because these two legs are the same, I have to divide it evenly to 40 and 40, don't I? So 2x plus 20 is a base angle. Vertex is 100 degrees, so the base angles must be congruent. Each one has to be 40. So I can set up a real quick equation, 2x plus 20 equals 40, which is a pretty easy equation. Yeah, it's 10. Okay? So we can do that. All I need to know in an isosceles triangle is one angle, and I can figure out the other two. As long as I know if that angle is a base angle or a vertex angle. But if the angle is obtuse, obviously it's not a base angle. Can I have obtuse base angles in a isosceles? No, of course not, because I have to have, if my base angles have to be congruent, if one's obtuse and the other's obtuse, I'm already over 180 degrees, aren't I? For 100 and 100, that'd be over 200. I can't have a negative 20-degree vertex. That wouldn't even make sense. So the base angles have to be acute. The vertex angle does not have to be acute. Case in point right there. So isosceles triangles can be right, they can be acute, they can be obtuse. They can be any of the three. And we can set up and solve equations. Very typical isosceles triangle type problem. Okay? I've got this angle is 40. This angle is 7x. Don't know this, don't know this. This angle is y over 3 minus 10. I need to solve for x and y. But I have two isosceles triangles here. Let's start with this one. This angle, which we call what? What's the name of that angle up there, the 40? What's the name of that angle in an isosceles? That's the vertex? Yes. Okay. The vertex is 40 degrees. How many degrees are left for these other two angles? Well, it's 180 for all three put together, but I used up 40 here, so I have 140 left, right? And because it's isosceles, these two angles have to be congruent. So I have to divide that equally between the two base angles, don't I? Because they have to be congruent. So 70 and 70. So this is 70. So 7x equals 70, so x is 10. Now, not done yet. This angle is also 70, making this angle 110. Right? So now in this isosceles triangle, I've used up 110 degrees. I've got 70 left, meaning each angle has to be half of 70, which is 35. So now I have y over 3 minus 10 equals 35. So I have to add 10. So y over 3 is 45 multiplied by 3. Y equals 135. Okay, y is not the measure of the angle, it's just a value for a variable. The angle is clearly not 135, the angle is 35. But the value of y in this case is 135. So that's a lot of what we're doing with this section with isosceles triangles, is using facts about isosceles triangles to either do proofs or to set up and solve equations. When we look at what's going to be in the homework tonight, this is one of the reasons I didn't sweat a little bit of chatter here, because I knew this was kind of a shorter section. And you'll notice that we're spending 2 days on this section. So a lot of stuff to talk about, a lot of things to go over. We do have a benchmark coming on Friday. Okay? We have a unit test coming next Tuesday. So you're going to want to be doing any makeups on that last benchmark. Most of this is pretty straightforward. You're solving things out. Now, be careful. Let me point something out that some people get a little bit mixed up with. All right? What parts of a triangle add up to 180? What parts of a triangle? It's kind of a different question. Okay? Yeah. That's a right triangle. I don't want a right triangle. I want an isosceles triangle. There we go. I'll get it. What parts of a triangle add up to 180? The angles add up to 180. But I see this a lot. Someone will say this is 2x plus 10. This is 5x minus, I don't know, let's see, 2. And this is 8. All right? And what am I indicating the measurements of there? Angles or sides? Sides. Are the sides going to add up to 180? No. They don't. It doesn't make sense. But I get a lot of students who get so used to the idea of you add up 3 angles to 180 that they get to see a problem like this and they add them up to 180. Because they just get used to that process. Oh, I'm seeing 3 things, I'm going to add them up, set them equal to 180. That only applies to angles, not to sides. So you got to be careful when you're looking at these things, when you look at the equations and stuff that are set up. Is it describing sides or angles? Now, I'm telling you this is an isosceles triangle. These 2 angles are congruent. I don't know what the angles are, I just know they're congruent. But that means that these two sides are congruent. So the equation is 2x plus 10 equals 5x minus 2. And I'm left with cancel, 12 equals 3x, so x equals 4. All right? Yeah, so homework I'll put back up. Just be careful. Be careful about this. It's 3 through 29 odd, 32, 38, 47, 52, and 53. Yep. Oh. Yep. Yeah. Yeah, because you weren't even here and you gave it a good shot, so.